Today's topic is radar range factors, branch type duplexer. So, in the previous session, I have told about them what is a radar, what is the principle of working in a radar, and what are the advantages, disadvantages of a radar. And I have told about the classification of radars. Under that, we have seen about the pulsar radar, and it is having some block diagram, an explanation of each block and how it works. It is the working of pulsar radar system. Okay, what are the advantages, what are the disadvantages of pulsar radar system? And we have already seen that number of definitions under the radar systems. Okay, so under that we have already learned that what is a duplexer and what are the types of duplexers and what are the functions of the duplexers, okay, in the previous session. But whenever coming to this session, we are going to be having a radar range factors. So what are the factors affecting our radar range determination? So in the previous class I have told that why we are going to be find outing or why we are going to be deriving the radar range equation. Why? Because in order to determine the maximum range at which any target can be detected, and it is also used to have a radar performance changes. So what are the factors we are getting some affecting of a radar performance, and by having the knowledge of radar range factors we can design a radar also. So these are the main things which are going to be used with our radar range derivation. Okay, so when we are having the duplexer is nothing but a switch which is used to connect as a transmitter at the same time receiver. That means which will connect to our antenna for both the transmitter section at the same time receiver section. So in order to operate a particular transmitter section, we are going to be connecting towards the transmitter part by the help of duplexer. That is nothing but it will works as a switch. Okay, so like this we are having a duplexer work. And what are the functions of duplexer means it is mainly used as a switch, means which will controlling of transmitter section at the same time receiver section also, and it will be providing some security towards our receiver section. Whenever we are transmitting some high frequency of signals from the transmitter part, it will not enter into the receiver section when it is having some process in our transmission section. So like this they are having number of functions with our duplexer. So in this session we are going to be seeing of the duplexer types and how it will works. And any radar, the output device is going to be indicators, that is nothing but a display unit. So in order to display what is that target and what is the height of the target, to have a clear picture of our target, we are going to be using a display units. Okay, so in this display unit, what are the types of display units, what we are going to be using, and based on what principle it is going to be working. So like this we are going to be having in this session. So first of all, radar range factors. In the previous session I have told about the radar range equation, final equation, that is R, that is target distance which is affecting across the target, that is given, that is going to be depends upon the transmitted power, cross section area, received power, wavelength, diameter, okay, effective aperture area. Like this we are having number of factors. So that are the factors which will be affecting our radar. That means the radar performance which will be depends upon the transmitter power, that is PT, and effective area of the receiving antenna, that is capture area is also going to be called, that is effective aperture area, okay, which can be given as AE, capital AE. And the third one is cross sectional area, that is radar cross sectional area, okay. And the fourth one is received power, that is PR, and wavelength lambda, okay. So what is the diameter of the antenna? It is also a main factor which will be involved in radar range factors. Okay, these are the factors affecting our radar range. That means in order to design or in order to have a performance of the radar, we have to know about this, all of the things which are going to be affecting our radar. Okay, so the next one is branch type duplexer. So in our duplexer is nothing but a switch. I have already told that the duplexer is nothing but a switch which is going to be used to connect the transmitter or receiver to the antenna alternately. So vice versa, it can having a connection the transmitter or receiver to the antenna. Okay, it is nothing but an which will be acting as an single pole double through switch. I have already told that single pole double switch means it is a single pole, it is having double switch. So that is nothing but an which will be connected at this time of some duration, otherwise it can be connected to this. So like this we are having as an single pole double through switch. Okay, which will be permitting the same antenna for our both transmission and reception. Okay, so like this we are going to be using this duplexer. So in this duplexer, how it is going to be acting as an transmitter section or how it is going to be acting as a receiver section. So to understand this, initially the branch type duplexer consisting of an two RF switches, two fast RF switches, which is nothing but a gas discharge tubes, which is made up of a gas discharge tubes. And in this, how it will works means it mainly consisting of two tubes. In our branch type duplexer, which consisting of two tubes, that is TR switch, that is calling as a transmit receive switch or TR tube. Shortcutly we can call as TR tube. And the next one is anti transmit receive, that is ATR switch, or we can also call as ATR tube. Okay, so in order to work with the duplexer as a switch, that is the single pole double through switch, for that we are having a two RF switches to work with this, to work as an duplexer. Okay, so like this, what is a block diagram which is going to be used as a duplexer means it is a branch duplexer which consisting of a transmitter and an antenna, and we are having a two tubes in our duplexer, that is ATR and TR. Okay, so when we are having some signals to be passed towards the transmitter to antenna, these two tubes are going to be activated. Okay, so in this, whenever the transmitter is going to be having some signals to pass, the TR tube is going to be short circuited. It is not in a open circuit, it is in the short circuit. So that means it will be short circuit means there is a path here. See, if it is going to be passing some signals towards the antenna, this area, this is going to be short circuited. That means the area is going to be closed in this part. Okay, so if it is closed, there is a path of this only. That means the transmitter will transmit some signals towards the antenna. But whenever the receiving some signals, so from the antenna when it is going to be receivers, this TR and ATR is going to be deionized. Deionized means it will be open circuit at this condition. So whenever it is going to be open circuit, these signals are going to be passing towards the TR. It is in the open circuit, that is the signal is passing, which will transmit and receive. That means the signals coming from this, it is going to be receiving, and it is going to be transmitting towards the receiver. So all the signals are going to be across this only, not will pass towards this. Anti means this is if it is going to be on, it is going to be off. If it is on, it is off. So anti is nothing but an opposite of something. Okay, so whenever we are having this operation, the receiver will receive this signals, not with the transmitter again. So across this we can have an operation of this. This TR and ATR tubes are going to be ionized at the transmitter section and deionized at the receiver section. So the name already indicates that it is an anti-transmit receive. So it is transmit and receive, it is an anti-transmit and receive. Clear? So when it is going to be on, it will be off. It is on, it is off. So opposite of this. Clear? I think so. Okay. So in this TR tube, the TR tube which will be consisting of an resonant cavity and associated with cathode tube. That means which will work as a cathode tube. We have well known about the anode tube and cathode tubes. Okay, so which will be acting as a cathode tube. The tube itself containing an inert gases, that is made up of helium and neon at low pressure, which will be made of a inert gas which is at low pressure. Okay, so when gas tube is in the operation, the resonant cavity permits energy to be transferred freely from input to output line. That means when it is going to be on, it will permit the energy to be freely passed towards from a device to another device. That means in terms of operation, it will be receives and it will be passing towards the receiver part. Like this, it can be operate in this. So ATR is a TR tube with no output. We don't have any output. So like this, we can understand that there is no path across the ATR tube. That means it will be ended at up to that tube only. Okay, so just it is going to be used to stop the operation across the transmission, at the same time reception part. So that can be having. So in this, what is the operation to be done means, whenever we are having some transmission part, that is during the transmission part, when transmitter is on, the TR and ATR tubes are ionized. This is going to be bond. So due to large power of the transmitter part. So whenever it is having the on condition, the TR tube acts as a short circuit at the receiver line. So whenever it is having the short circuit, there is no path to transmit towards our receiver. It just transmits to the antenna only, not with the receiver. Why? Because in this session I have told that if it is short circuit, there is no signal passing towards the receiver. It just passing towards the antenna. Okay, so like this it is going to be done across the transmission. That means TR tube acting as a short circuit at the receiver line and open circuit at the transmission line. So automatically ATR tube acts as an open circuit at the transmission line. So the transmitted power reaches the antenna, but it does not enter into the receiver. So opposite of the transmission is nothing but a reception. So whenever the transmitter is in the off condition, the both switches are deionized. Okay, so when it is going to be deionized, the ATR tube is going to be acting as a short circuit. But whenever it is having the TR tube, which will acts as an open circuit, because I have told that TR and ATR is the opposite of that. That means if it is the TR is going to be ionized, it is going to be on condition, and the ATR tube is going to be off condition. If the ATR tube is the on condition, TR is going to be off condition. Okay, so like this, opposite is going to be done within this TR and ATR tubes. And TR tube, so echo signals coming from the receiving antenna travels towards the receiver but not goes to the transmitter part. So like this, it is going to be done within our duplexer. And coming to the indicators, I have told that in order to display the radar information, we are going to be using as radar indicator or display. We are going to be calling as display or indicators. We are basically based on the operation, it is classified into display modulated systems. Okay, that display modulated systems are going to be having the two types, that is deflection modulated display, and next one is intensity modulated display. Already the name indicates that it is a deflection, it is movement, And the second one is intensity. So brightness, we can use that. Intensity means all are well known about our intensity. Why? Because whenever we are having some phones, we are going to be having some changes of the brightness, intensity, color. Okay, so like that we are having most probably idea. And also in our TV also we are going to be changes them, intensity part, color, okay, brightness, like this we are going to be increasing. So the next one is, whenever we are having the deflection modulated display, in this the target is going to be indicated by the deflection of electron beam. That means the movement of the electron beam, based on the movement of the electron beam, the target is going to be detected. That is going to be calling as deflection modulated display. And the next one is intensity modulation display. So what is this means? The target is going to be indicated by intensity of electron beam, by having some brightness changes of the electron beam. The first one is deflection of the electron beam. It is going to be calling as deflection modulated display. Other than that is going to be calling as intensity modulated display. That means the target is going to be indicated by intensity of the electron beam. Okay, so in this we are having number of types of indicators or number of types of displays. So under that we are going to be calling as scopes. The radar displays can be classified into following types. That means how it is going to be working, on that base we are having number of displays, and that displays are going to be calling as scopes. Why? Because we are having oscilloscopes. It is nothing but it is also a display which will be having some signal displaying. Okay, so like that only we are calling as scopes. So A scope, B scope, C scope, D scope, like this we are having number of types. Under the A scope, it is a two-dimensional radar display. In this, the horizontal and vertical coordinate represents the range and echo amplitude of the target. So each scope which is having specialty. So A scope is going to be depending the range, at the same time amplitude of the target. Okay, and what is the type of this is but nothing but an deflection modulation takes place in this. Okay, it is mainly used for manually tracking radar. And the B scope is going to be two-dimensional radar system only, display only, and in this also the horizontal and vertical coordinates represents the azimuth angle and range of the target. So azimuth is nothing but an horizontal directions mainly. So we will have a next session about this azimuth angle, and which will shows the range of the target also. So the B scope having the intensity modulation takes place, and is mainly used for military radars. And the C scope, it is also a two-dimensional radar display, and the horizontal and vertical depends the azimuth angle and elevation angle representatively, and at the same time it is an intensity modulation takes place in this. And the D scope, if the electron beam is deflected, our intensity modulated spot appears on the radar display. That means the deflection of electron beams, our intensity is going to be having a spot, we will observe as a spot, okay, on the display due to presence of the target. Then it is known as blip, which will having some sound. Okay, so the C scope becomes D scope when the beam extends vertically in order to provide the distance. That means C and D is having the both same conditions, but whenever the C scope which will having a spot appears on the radar display, which will notify that there is a presence of radar, there is a presence of target. Okay, so for that which will be having some sound as a blip. Okay, so the C scope becomes as a D scope when the blip extended vertically. That sound is going to vertically, it is going to be moving as that, we are going to be having a D scope, and which will shows as a distance. The C scope and D scope is having the relation between that. And the next one is E scope. So what is an e-scope means? It is also a two-dimensional radar display, and the horizontal and vertical coordinates represents the distance and elevation angle respectively. So it is also a intensity modulation takes place. So in our f scope, it is also aimed at the target only. All of the scopes are going to be used for the target only, which will displace the target as a centralized beam. Okay, so D scope and F scopes are both are going to be same. Okay, just which will be having some vertical directions only in our D scope, but in our F scope it is having both conditions, that is horizontal and vertical aiming. So when it is having the two bleep sounds across the horizontal and vertical, that will indicate as an errors respectively. Okay, that is the main indication of F scope. And G scope is going to be, it is also aimed for at the target only, and which will be centralized beam is going to be seen in our F scope type, same as that, and which will be displacement of the dip. In this F scope, whenever the bleep is going to be representing the horizontal and vertical, that will be showing the error. But in our G scope, the displacement of the bleep is representing as an error. Okay, that is the main intention of G scope. And the next one is H scope. So it is a modified version of the B scope in order to provide some information about the elevation angle of the target, which will displace the target as two bleeps which are closely spaced. Short bright line is going to be seen, and the scope of the line is also going to be seen. That is proportional to the sine of the elevation angle. That is nothing but the H scope is mainly used for to have an elevation angle of the target. So having some information about the elevation angle. And the next one is I scope. So if the radar antenna is aimed at the target, this scope displays the target as a circle. That means the target is going to be showing as a circle. Okay, which will having the radius of this circle will be proportional to the distance of the target. If the radar antenna is going to be aimed at the target incorrectly, then I scope displays the target as a segment instead of a circle. That means the scope, if it is going to be placed correctly placed in our radar antenna at the target, okay, so at that condition only which will shows as a center as a circle, that means the target as a circle. But when it is not correctly placed, it is incorrectly placed, at that moment which will be not shows as a circle, which will show as a segment, okay, a part. Okay, like this, that is going to be used with our I scope. And then J scope, which is a modified version of A scope, and which will be displays the target as a radial deflection from time base. That is nothing but whenever we are placing an antenna or from the transmitter to antenna, that angle is going to be maintaining across the target. So based on that base of the target, it is going to be using a radial deflection. The movement of scope is going to be done within this J scope. So the next is nothing but an K scope. K scope is going to be modified version of A scope. If the radar antenna is going to be aimed at the target, then K scope displays the target as a pair of vertical deflections which are having the equal height. If the radar antenna is aimed at the target incorrectly, which will be pointing as error. So the magnitude and direction of the pointing error, which will depends upon the difference between the two vertical deflections. That is the K scope. And next one is the L scope. If the radar antenna is aimed at the target, which will displace the targets as a two horizontal bleeps having equal amplitude. Okay, so one horizontal bleep lies to the right of the central vertical time base, and the other will lies to the left of the central vertical time base. And the next one is M scope. It is the modified version of the A scope, and adjustable pedestal signal has to be moved along the baseline till it coincides the signal deflections. The M scope, it is very rarely used, but in this way we can find out the target distance can be having. So that means in this way, when we are going to be using, the target distance can be easily determined by the M scope. Okay, and the next one is N scope. It is a modified version of the K scope, and adjustable pedestal signal is going to be used for measuring distance. The next one is O scope. We are having number of types. Under that we are having this O scope. It is a modified version of the A scope. We will get O scope by including an adjustable notch to the A scope for measuring distance. Already I have told that the M scope is also going to be used for measuring distance, and N is also going to be used for measuring distance only. O is also going to be used for the measuring distance only, but an adjustable is going to be done across the A scope. That means a notch is going to be adjusted to our A scope. And the next one is P scope. It is a radar display which will using intensity modulation, so which will display the information of echo signals as a view. Range and azimuth angle are going to be displayed in a polar coordinates. Hence it is calling as an plane position indicator or PPI display. It is mainly used in our radar systems. When it is going to be used when the moving target is going to be modified or moving target is going to be indicated. It is mainly used for the moving targets. And the next one is R scope. It is also a radar display which will using the intensity modulation technique, and the horizontal vertical which will depends the range and height of the target respectively. So for these reasons it is calling as an range height detector or RHI detectors. So like this we are having this scopes. Okay, these are all of the scopes which are going to be used for a different applications. So in order to determine height, or in order to determine the position, or in order to determine the distance of the target from the transmitter, okay, in order to display the particular target, we are having number of scopes like this. From the A scope to R scope we are going to be using different applications part. That means in order to display the target, in order to have an information of the target, in order to have an angle of the target, in order to have a direction of the target, we are having number of scopes. So the next one is quiz. So please note this question, that is number of patrons, radiation pattern required to specify the characteristics are. That means how many number of patrons are required to specify the characteristics. That means we are having radiation pattern. To draw the radiation pattern, how many patrons are going to be representing the specific characteristics? Note this question please. Okay, so when we are having this question, that means how many number of patrons are going to be required to specify a specific characteristics for an antenna? The answer is A, that is 3 number of patrons. 3 of patrons, radiation patrons are going to be required to specify an characteristics of an antenna. Okay, so the next question is the solid area through which all the power radiated by an antenna is going to be calling as the solid area through which all the power radiated by an antenna is going to be calling as, first option is beam area, second option is effective area, third one is aperture area, the fourth one is beam efficiency. So please note this question. These are useful for our ESET examination. Okay, so please note this question. Okay, the solid area through which all the power radiated by an antenna is going to be calling as beam area. So around the antenna, the solid area is going to be covered. That means which are having the power radiated by an antenna, around us we are going to be calling as beam area. The next question is, if an antenna radiates over half a sphere, that is, full sphere is not going to be done, half a sphere, only half, directivity of the antenna is, how it is going to be having some direction, how it will works when the antenna is going to be radiating over a half sphere. So how the direction is going to be having of the antenna, whether it is having 2, whether it is having 4, whether it is having 3 or 1. So please note this question, please. That means if an antenna radiates over a half a sphere, what was the directivity of the antenna, whether it is having 2, 4, 3, 1. The answer is 2. The directivity of an antenna means it which will be flowing towards the 2 direction, two way it is going to be having some area to be covered with a antenna. The next quiz is, ideally the number of point sources an antenna can resolve is numerically equal to. That means an antenna, if it is going to be used which is having a 2 points, that means which is having the antenna is going to be working at 2 points. So what are that? That is going to be numerically calling as, the first option is gain of the antenna, the second option is directivity, the third option is beam efficiency, and fourth option is beam area. What is that? Okay, please note this question, please. Okay, ideally the number of point sources an antenna can resolve is numerically equal to is going to be directivity. Is calling as directivity. That means the number of point sources of an antenna can resolve is numerically equal to, it is not a gain of an antenna, it is not a beam efficiency, it is not a beam area, it is nothing but a directivity of an antenna. So effective aperture is a parameter of the antenna that gives a physical aperture of the antenna. Is it true or false? When we are having an effective aperture in our radar range equations, whenever we are having an factors affecting of our radar performance, so under that one of the parameter is effective aperture, that is AE. Okay, so effective area is also going to be calling as. So what is this is a parameter of an antenna that gives the physical aperture of the antenna. Is it is giving some physical aperture of the antenna? Either yes or no. That is true or false. So please note this question, please. Okay, so effective aperture is the parameter of the antenna that will gives the physical aperture antenna. Is it giving same? Is it giving some information of that it is a physical aperture of the antenna, or yes or no? What is an answer? It is an false. It will not having an parameter of an antenna that gives the physical aperture of the antenna. Next one. Dash of an antenna is defined as a ratio of induced voltage to the incident electric field. Dash of an antenna is defined as a ratio of the induced voltage to the incident electric field. Ratio of induced voltage to the incident electric field. What is that? That means it is a effective height or a gain of an antenna, or a directivity of an antenna, or a loss of an antenna. What is the parameter of an antenna is defining as ratio of induced voltage to the incident electric field. What is that parameter? So please note this question, please. Okay, so dash of an antenna is defined as a ratio of induced voltage to the incident field. What is an answer? A, that is effective height. Effective height of an antenna is defined as the ratio of induced voltage to the incident electric field. Okay, so the next one is the antenna in which location of the feed determines the direction of the lobe R. So what type of antenna which will be in which the location of feed determines the direction of lobe? And when we are having some types of antennas, in that different types of antennas are there, so which antenna is going to be determining the direction of lobe is going to be equal to the location of feed. that means which will in which the location of feed which will determine the direction of the loop. So what are the type? Is it a wire antenna or loop antenna or a helical antenna or horn antenna? Please note this question. So the antenna in which the location of the feed determines the direction of the loop. What is an answer? So what is that? It is an wire antenna, not with the loop antenna, not with the helical antenna, not with the horn antenna. The wire antenna which will be in which the location of the feed determines the direction of the loop. So next one, based on the size of the loops, loop antennas are classified as small and large loops. This is only the classification of loop antenna. Is it true or false? That means based on the loops, the radiation, when we are drawing the radiation patterns, we are having some loop antennas. So in that loop antennas, whether it is classified into small loop antennas and large loop antennas, since it is true or false. So please note this question. So based on the size of the loops, the loop antennas are going to be classified as small and large loops. This is the only classification of loop antennas, whether it is true or false? It isn't true. It means whenever we are having some size of loops, the loop antennas are classified as an small and large loops. Is it correct? Yes, it is correct. True. It is classified into two parts, that is small loop antennas and large loop antennas based on the size of the loops. Okay. So thank you. So whenever we are having in this session, I have told about the number of things based on the number of types of scopes which are used for different modulation techniques, that is deflection, at the same time intensity modulation techniques we are going to be used. Okay, so not only with that, we are having some duplexer also. So I have told in this session, I have covered the radar range factors. What are the factors affecting of our radar performance? And not only with that, we are also concerned with the branch type duplexer, and under that what is the operation involved in that, what are the tubes are going to be differentiated, that is two types of differentiation, and what are that means TR tube and ATR tubes, and what are the indicators. We are having number of indicators, but when you are having the indicators, the displays are going to be basically what is the modulation techniques used, based on that it is going to be classified. So it is basically two types, that is basically it is having two types, that are deflection modulated displays and intensity modulation displays. So when we are having the deflection modulated displays, the target is going to be indicated by deflection of the electron beam, and intensity modulation display, the target is indicated by the intensity of electron beams. So under that we are having A scope, B scope, C scope, D, E, PPI, RHI. Okay, all of these are going to be having in this type. So in this session we can have an clear explanation of this parameters, radar range parameters, and branch type duplexers, and what are the types under the duplexers, and what is the operation of duplexers, and what are the indicators and what is the modulation techniques used under this. Okay, all of this can be done with this. Okay, thank you so much.